will say the projection of straight lines. Projection of straight lines. In this case, first we need to consider a line inclined to one plane. Inclined to one plane. That one plane may be HP or VP. Inclined to one plane and parallel to other plane. Parallel to other plane. This is the first case. The second case, line inclined to both the planes. Inclined to both the planes. Right. Now first case we will see, that is line inclined to one plane and parallel to other plane. What are the different possibilities? See, when line inclined to one plane, okay, for that purpose, this we can consider this is in a horizontal plane, this is the vertical plane. Now see, a line inclined to one plane, let it be line. If it is like this, right? Now this line is inclined to HP and parallel to VP. Suppose if you consider like this, this line is inclined to HP and parallel to VP. Okay, both the directions, both the projections are correct. Here we can consider this line like this or like this, right? Now suppose if you imagine like this, this is inclined with the HP, but it is not parallel to VP. One is the fixed point, okay? Other one is the moving point, okay? Fixed point and moving point. Next one. In the problem, with respect to horizontal plane and vertical plane, the fixed point position, okay, that need to specify. Suppose if it is not specified, we can take randomly, but most of the cases it will specify. Okay, after that the inclination with HP, okay, that we can consider as theta, right? Now the second one is, this is inclined to HP and parallel to VP. Now see, now the line is parallel to HP and inclined with VP. Here also the fixed point position need to specify in the problem. Suppose if you consider a line like this, then the line is parallel to both HP and VP. Okay, these cases we need to consider and we need to draw the respective front and top views. Now we will see the problems. A line is inclined at 45 degrees to VP and parallel to HP. A line is inclined at 45 degrees to VP and parallel to HP, and the lower end is above HP 20 mm, in front of VP 15 mm. Above HP 20 mm, in front of VP 15 mm. Okay, now see, the line inclined to VP. How much angle given? That is 45 degrees. 45 degrees inclined to VP. Right. Next one. It is parallel to HP. Right. And the lower lower end is above HP 25 mm, lower end above HP 25 mm and in front of VP 20 mm. Okay, this is the line given. Now just imagine this line first. For that purpose, we need to draw the principal planes. Okay, and here this is related to the position of fixed end. Okay, first we need to draw the position of fixed end. Okay, here the lower end above HP and in front of VP. The lower end above HP 25, therefore this is 25, and in front of VP 20. Then this is the respective point A, let it be lower end is A position. Next, the line is inclined with the VP 45 degrees parallel to HP. If it is parallel to HP, the same 25 same, and it is inclined at 45 degrees. Okay, this is at 45 degrees. Now we can draw the respective positions. Right. Now the required line is this one. This is the line AB. Okay, it is parallel to HP. If it is parallel, in the top view we can see true length and true angle of inclination. That means this is equal to 45 degrees and this line is it's a top view. Let it be A, B. Right. Now come to front view. If you see the front view like this, then A point here and B here, and only this line we can see. A, B. Right. After the rotation, this top view will be below the reference line. This is the reference line. Okay, and this is above HP. Right. And one more thing, when we rotate it, okay, this line will be exactly perpendicular to the reference line. And when we rotate it, this also, this one and this one, exactly perpendicular. Okay, exactly perpendicular. Right. This is the imagination. Now come to the drawing on the drawing sheet. See, it is very simple to draw. First draw XY reference line and locate the position of a fixed point. Lower and above HP 25 mm. Therefore, above HP 25 and in front of VP 20. This is 25 and this is 20. Right? Next one. The line is parallel to HP. Here, which view we need to draw first? The view which gives the true length and true inclination, that view we need to draw first. In this case, top view gives the true length and true inclination. Therefore, with 45 degrees angle, the top view first we need to draw. This is 45 degrees. This one is 45 degrees. Right. And true length, the line length, the line is inclined, the line length, let consider it is 50 mm. The line length AB, let it be 50 mm. Okay, and that line length we need to mark here 50 mm, and this is the top view. This one is top view. Right. Now, how we can draw the front view? Here we see this is the projector, this line and this line. And now we need to draw the projector. Here, this is the projector and this is the projector. Therefore, after the rotation, the projector will be perpendicular to the reference line. Okay, therefore draw like this. Next, and this line is parallel to reference line. Okay, therefore we need to draw a parallel line to reference line. This one be A dash and B dash. Okay, this is a solution of the problem. Right. A line of 50 mm length, a line of 50 mm length is inclined to HP 45 degrees, inclined to HP 45 degrees and parallel to VP. And the lower end of the line is above HP 10 mm, in front of VP 10 mm. Draw its projections. Right. What is given in the problem? AB line length equal to 50 mm and lower end A is in front of VP 10 mm and above HP 10 mm. Right. And this line is inclined to HP. Here the inclination with HP we can call theta. Theta equal to 45 degrees. Right. And the lower end position are already given. It is parallel to VP. Right. Now imagine the respective line position. For that, this is the principal planes HP and VP. Now the lower end position we need to mark first. It is above HP 10 mm and in front of VP 10 mm. Okay, therefore this is the position. This is the lower end position. This is A. And it makes an angle of 45 degrees. 45 degrees with horizontal plane. Okay, this angle equal to 45 degrees. Right. Line length equal to 50 mm. Right. Okay, and this line is parallel to VP. Therefore, when it is parallel to VP, in the front view we can see the true inclination of line with HP and true length of the line. Therefore, this is equal to 45 degrees and this length A dash B dash front view is equal to 50 mm only. Right. Now come to top view. In the top view we need to project it downwards and we need to project A also. And if you draw it, this is the top view. This is A and this is B. Right. Now we will darken the respective views. Okay, the given line. This is the line what we considered. This line is 50 mm length and makes an angle of 45 degrees with the horizontal plane. Okay, and it is parallel to HP. That is the reason true length and true inclination is visible in the front view. Therefore, in this case, we need to draw front view first. Now, if you see the top view, this is the top view, right? And this is projection end projector E for A, and this is the end projector for B, right? Now we will draw the respective diagram in the drawing sheet. Now draw the reference line XY and mark the position of lower end 10 mm above HP and 10 mm in front of VP. This is A dash, this is A. And in the front view, true length and true inclination is visible. Therefore, draw a constructional line, okay, and with the 45 degrees angle, right? And the true length of the line equal to 50 mm. Mark 50 mm, okay? You need to darken the required line only, right? Now to draw the top view, project it downwards and draw the parallel line to reference line, because this is parallel to reference line, right? And this is the required top view B. This is B dash, right? This is the solution of the problem. When a line is parallel to horizontal plane, in the top view its true length and true inclination we can see. When a line is parallel to vertical plane, in the front view true length and true inclinations we can see. When a line is parallel to both HP and VP, we can see the front view and the top view with the true lengths and